Hello and welcome to my channel. Today we are going to talk about the big O notation and what is it, what are the different type of big O notation and how it is useful in the software programming. So big O notation is the way to describe the efficiency of your algorithm, specifically how your logic will perform as the number of input grows in the size. So this is very important because as the input size grows, the number of operations it is performing inside your logic is also grows, and which indirectly impact the performance of your code. So this big O will help us to understand the performance of your algorithm. It helps us to compare the efficiency of the different algorithm so that we can choose which one is the best suited for the particular task or how we can optimize it further. So some of the good example of big O notation includes O of n, which is a constant time, O of n, which is a linear time, O of log n, which is a logarithmic time, O of n square, that is quadratic time, and O of 2 raised to n, and that is the quadratic exponential time. So let's look at the different examples of the different big O notations. So let's start with the constant time. What does that mean? As the name suggests, it is a constant time. That means irrespective of the how big your input or how your input is growing, the algorithm which is going to perform on that input will produce the output in the constant time. So let's take an example. So here, this is the method which is always returning the first element in the array. Now this is just an example. Now irrespective of array size, if it is 1, 2, 3, 4 or millions of the elements in the array, it still produces output in the constant time. So that is called O of 1. That is a constant time operation. Now let's look at the linear time. What is a linear time? Linear means as your input grows, the number of operation it takes for each input, it also grows with the number of elements in the input, right? So that means it is linear to the input size. Now let's take an example to better understand this. So this is the method which actually uh, check if particular element exists in the array or not, right? So now if you look at this will always like go in the loop, right? If you look at this, so this is the loop. Now for every element it will check if the number which are trying to find it exists in the array or not. If yes, then it's returned true. Now it is possible that it can return immediately, because if it is the first element then yeah, it is fine. But what is the upper bound? Upper bound, it can go up to the length of an array, right? Or if it doesn't find anything, it may return some empty string or something, whatever. So this is called linear time or n. So if the array is of length n, then the time complexity of this algorithm or this function is O of n. That is called the linear time. Now let's take an example of the next bigger notation, which is O of log n, and that is the algorithmic. What does it mean? The number of input as it grow in the size, the operation is your code is going to perform, it is performing in the logarithmic time. Let's take an example of this. So you might know that if you have sorted array and if you want to find some element in the sorted array, then what you will do, like this is the binary sort in terms of like when you pass a sorted array, it's find the mid elements and then it see like what value you are trying to find, if it is greater than or less than the mid element, and based on that it just adjusts the left and the right. So what does it mean? That means every time this loop runs, the while loop, it actually the dividing the the total elements into the half. So it is actually log of n time. So that's how, so binary search is always perform the operation in the O of log n time. It is possible that it can done in constant time. For example, if the mid element is the element we are trying to find, then it in the very first loop it will just find the element and it will return the element, right? That is possible. But maximum it goes till O of log of n. So this is the logarithmic time. Let's look at the next one, quadratic time. What does that mean? That means running time of the algorithm grows at the square of the size of the input. That means if your input is of n size, then it will be your code will perform in the n square time. Let's look at an example. So this is the multiplication we are doing between two arrays. We are multiplying every element with every element of another array. Now, if you look at this is the outer loop, right? So this will run in the O of n time, and this is the inner loop. So for every element of the outer loop, this inner loop is going to run, which is again O of n time. So this will go into n times n, that is n square, right? So this is nothing but O of n square. Now let's look at the next one, which is exponential time. What does it mean? Is algorithm grows exponentially as your input grows. Now this is very bad in terms of performance, and it is never recommended that if your code or if you find that your big O is O of 2 raised to n, then you should not be doing it, or you should refactor your code to make it more optimal. Let's take an example. So this is the Fibonacci series. So in the Fibonacci series, what is the Fibonacci? Is actually the the given element is the sum of the previous two elements, right? So this Fibonacci code we return as a recursion, means the Fibonacci function itself calling, to itself for the previous two element, right? So it's exponentially growing every time. So this is the exponential time. So hope you like this concept and this video. If you like, please subscribe and like this video. Thank you. See you in the next video.